All right, guys, this is an introduction to graphing lines. It gets a little more formal in a little bit, but this is just the basic idea here. So in class, we've already spoken about this thing being a line. And if I wanted to find the slope of that line, I would do the rise over the run. And if I kept doing that, I would keep landing on this line. And I can do that forever. That's assuming that I've already been given the line. What if I don't know what the line looks like yet? I need to be able to graph it. We also found out when we started talking about the slope that we need a minimum of 2 points in order for us to know what the line is. So 2 points determine a line. All right, so if we understand that 2 points determine a line, if I wanted to draw a line, if I had a point and a point, I could draw a line through them. Sorry, missed it. There we go. Right? So my goal really is to find at least 2 points. Now, if I give you a function or an equation, I could find those 2 points just by plugging it in. So what if, for example, I said, and I have one here in Alex, I can use this table to find out what the actual points are on a line. So if I tell you that y is equal to negative 5x plus 1, then when I let x equal negative 1, then I have y equals negative 5 times negative 1 plus 1, or 5 times negative 1 is positive 5 plus 1, or 6. So my y value here would be 6. So that's a point. I could find another point by using x equals 0. So if x is 0, then y is equal to negative 5, and then instead of x, I write a 0 plus 1, which gives me 0 plus 1, or 1. So this would give me 1. And when it's 1, now that's all I really need to graph a point. This gives me the point negative 1, 6. This gives me the point 0, 1, and I could use that to graph it. Now in Alex, it's going to ask me to just get practice using this function rule by plugging numbers in. For the first two, I'll get that. When I plug a 1 in there, I'll get a negative 4. When I plug a 2 in there, I'll get negative 9. Unless I did the math wrong or too quickly, we're good. Now, at some point, though, I'm just going to say, you know what, graph this line. And I'm going to do the same idea. Now, I'm not going to tell you which values to put in there. You can choose any values you want to. So if I tell you that y is equal to 2x plus 2, I want you to choose an x value and then see what the corresponding y value would be. So let's just let x be 1. I'm just making that up. Any x you want. Let's let it be 1. Well, when I plug that in there, then y is going to equal 2 times 1 plus 2, or 2 plus 2, or 4. So I get the point 1, 4. If I plug in a 3 in here, then y is equal to 2 times 3 plus 2, which is 6 plus 2, or 8. So I get the point 3, 8. So I can go here and I can plot those points. I can plot in, let me put my parentheses here, and here. I can plot the points. Actually, I can use a line. I think the first point is at 1, 4, and then the second point is at 3, 8. And if I check that, we should be okay. So I can go through and do that as many times as I want. Now, sometimes the 2 points that you can find are called the x-intercepts and the y-intercepts. And I'll do a separate video for those. Those are just special cases of 2 different points. But you can use those things. You can also look at that in terms of like the equations of lines that are just x equals, or equations of lines that are just y equals. So I'll do that in a separate video, but I just wanted to introduce the idea of graphing lines. All you need are at least 2 points. And if I just give you the equation, all you got to do is plug in different values of x, see what the values of y would be, and then you'll be good. All right? It doesn't matter which x's you use. I would, if I were looking at, say, number 2, for example, though, if I were looking at number 2 or number 4, I probably wouldn't choose something like x equals 50 because it's off the chart. I won't be able to graph that on there. But you can choose any value you want so long as it works.